Hello audience, and hello to the jury. My name is Phil Botwich, and this is the rest of the team. And our team name is Zeus, and our slogan is Batteries Free Home. So before I get into the actual, how can you say, the actual presentation, I just want to quickly make a mental exercise for each person in here to consider their daily activities throughout the day. And then compare it to the person next to you. So what we usually do is, we get up in the morning, and then we turn on the lights in our homes, we turn on the TV, we cook some breakfast, we go to work, and then we come home again, cook some dinner, take a shower, etc. And the person next to you probably also does this. And we know for a fact that the person next to you does this because this is actually reflected in the amount of electricity that we use throughout the day. So what you see up here on the screen is a graph which shows the electrical consumption of an average household in Denmark throughout the day, and then we have time on the x-axis. We have two peaks. We have one in the morning when we all get up, and we have one in the evening when we get home from work. You can probably recognize this behavior pattern yourself. If we move on to the next slide, I will elaborate a little bit further. The red line is the electricity consumption over 2 days. This is actually data pulled from a couple of days ago. The blue field is green energy produced by wind turbines, and the green line is the spot price of electricity. So what we actually see here is that we have whenever the demand is highest for the electricity, we are not producing so much electricity, green energy at least. And that means that the price goes high in conjunction with supply and order. So our idea is, what if we can take around, you can see around from midnight to 4 o'clock in the middle, there is a huge drop in how much power we consume. And we are actually producing way more green energy here. So what if we could take this energy here and we could move it to the peak demands and therefore peak shave for all consumers? This is where our solution comes in. Our solution is that we want to peak shave, and this requires some form of battery electrical storage system. However, we do not only want to peak shave, we also want to help different sectors. So right now in Denmark we see a huge increase, almost an exponential increase in electrical vehicles. And at one point the battery of these electrical vehicles will be out of commission. However, these batteries are not completely used up because they still have some capacity left at the end of their life. And therefore, our plan is, because the capacity of these batteries is still overly dimensioned, we plan to use these used batteries in our solution to be able to peak shave, therefore providing not only a more cost-effective solution for the consumer, but also alleviate how we discard the lithium-ion batteries. Moving on, the deal is that we have a product, a complete solution, and we will take money from private consumers and thereby install our solution. And this could be done with a one-time purchase, or it can be done via a leasing plan. So, as you can see, this is a more technical drawing of our idea. So the blue box is our system. If you take that out, you are simply taking energy from the grid and supplying it to your appliances in your home. With our solution, we can implement this in the middle, where we can actually take energy from the grid, wherever it is the cheapest, supply it in our battery electrical storage system, and that from there we can have some form of power conversion to actually retrofit this solution very easily into every single home which has these solutions, and thereby powering all your appliances. The hard numbers for our business plan is as such. We can see the total cost up at the y-axis and the amount of years on the x-axis. If no solution is installed, we will simply see on the red line that we just spent money on our electricity bill linearly. If we buy a solution, a brand new solution with completely new batteries, we will have a larger upfront cost, but we can see that the slope is actually lower because now we are saving money on our electricity bill. If we use our solution, we are able to reduce the price of this upfront cost, and therefore we are actually able to reduce the time when the money is made back from this solution just below 10 years compared to the regular solution, which would be around 25 years. We crunch the numbers and we can build this solution for around 15,000 crowns. And what the price which the customer will receive would be 30,000 crowns, meaning that there is a margin of 15,000 crowns to be gained. And we have calculated that the savings from such a system is around 3,000 crowns a year. So, to wrap it up, I quickly want to talk about the scalability. Obviously, every home in Denmark can have this solution. But after this, we can scale it up to commercial use. And when we have the commercial, we can also have the industry. And ultimately, everybody in our society will be able to peak shave and flatten this curve. And when we do so, we are increasing the medium or the base load for the entire electrical grid, but we are shaving the peaks. And this is a very good thing, because when we can do this, we can actually increase the capacity for green energy solutions, because currently these green energy solutions cannot sustain these very harsh peaks that we have right now in our society. Yes. Thank you very much for your time.